Hello Twitch, hello world, hello YouTube, hello everybody. We are here starting again with our episode number 11 of building a Game Boy emulator with Rust. First of all, I just saw that Saturno Z Mart just followed us in Twitch, so maybe he will join us in the chat because he always give us some comments on our YouTube channel. So let's address his comments first. So he said that I made two mistakes, and yeah, that's true. I really did that. So he said that in the instructions JRN, the address should be some the program counter. So here I already fixed it. So this step was not here, but it is now. So thank you again, Saturno Mart, for this heads up. And also he said that CP instruction should be, this comparison should be between A and the value itself. It was like this. What we did that yesterday was this, but this is wrong because CP this value should be compared against the register value directly, not from the memory. That's not an address of the memory. That's a comparison directly. So yeah, and that's right. I already checked in other documentations. And thank you again, Saturno Martin. Oh, let me do something. So yeah, we finish with this. Yesterday, those guys from Reddit, Rust, that was amazing because I posted it there, and I received a lot of a lot of comments, and a lot of very good comments. And one of them was saying to me to announce our Twitch live here. So I will do that now because we are starting. So then I can do this. And I will put the name of our currently episode, just to have more people watching us. Okay, so let's stop off propaganda and start working again. So yeah, so even with those errors, we still get stuck on that SAM. So now it's I let with the bug, let the code run. And we will see that I think it gets there. Yeah, I think it's get there. So decoding PC 80. Oh, not there yet. Let me turn off the debug. I'm just printing for each for each loop in each instruction. I'm printing the memory. And then yeah, we are still stuck. No, we are not stuck. Okay, let me do something here. I think we have too much instructions here, so I will put this debug on the CP and see if you get there. Yeah. Yeah, so yeah, so we are doing this loop here. So let me just do one thing. I will do okay, I will put it here and I will turn on the debug. Then okay, so when we start seeing our memory dump from here, it means that it gets there. Not yet. Yeah, it's there. Yeah, already. If you see, we already. So yeah, here it is. So let us see. Just to prove that we need to implement the display today. Ha ha ha. Wait. Let me do clear. Okay, and run again. I want to go through that. Okay, so I think we are there. Oops. The buffer is too low. Let me do something else here. Just to me to be able to see. Like, oh, this music is so sad. I don't like that. I will move back to our let me put those. Yeah. So this is nice. If you guys have any idea of other free music to us to play here, just ping here. So yeah, let's do that. And so we are just dumping a lot of instructions and we eventually get there. Oh, well, and I can do this. Of course, my horse. No, I want to see this. So pam 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 pam. Yeah. We got that. Yeah. So here we are. We did this here. So we came here. We get that, and then eventually we return. So we return from here. Then we get back to F. So to F. So yeah, we return here. Oops. Sorry about the size. Hey, DevTron, hello. Will this be available on YouTube later? This stream? Yeah, sure. In the channel. As soon as we finish here, I will upload to the YouTube as usual, and you will find there the old episodes as well. So this is the number 11. All the others are there already. Thank you, Chris Salad Zombie. Thank you for the following. I really appreciate that. Thank you. Oh, more 4 followers and we get our first goal. Oh, thank you, DevTron. Thank you a lot for following. Oh, so this as episode 1. No, this is the episode 11. Yeah, we are already in the episode 11. But all the other episodes are there already. Thank you, DevTron. Thank you a lot. Thank you. That helps me, that motivates me to keep doing this. And yeah, we will definitely go to the end with this emulator. And the end means playing Pokemon Red or one of those Pokemons. Doesn't matter. And of course Tetris, Super Mario, and all others. But if we can play Pokemon, we can play almost all Game Boy games. So yeah, so here we are, instruction D, and program counter is 2F. So program counter is 2F. Yeah, and this is a perfect time to learn Rust because it's getting more and more popular. Also, Rust is from Mozilla, and I saw other big companies is starting talking about that. For example, Libra, that new blockchain currency from Facebook that they will use for, I think, for payments and so on, is built with Rust. If you see in GitHub, Libra here. Our mission is to enable blah blah blah. This Libra is built in Rust, as you can see, Rust, and this is from Facebook. Let's see on their site. This is Libra. Welcome to Libra. Blah. So this is the Facebook. Open source cryptocurrency. It's like a Facebook Bitcoin. So this is made using Rust. There are a lot of talks from Microsoft these days talking about Rust, and a lot of stuff being done with Rust. So yeah, this is a very good time to learn Rust. It's a low-level programming language. It's a system programming language, and it's easy to learn. If you know, it's easy to learn, and there is a lot of documentation and community out there. and the community is very open, and you feel you're gonna feel that if you start learning Rust. And this could be one way to learn, building an emulator. uh, I used to say that building emulator is hard, but at least you can play in the end when we finish that. So okay, getting back here to F. So we are here. Then oh, this is DCP, not that CP. Not that. I stopped at the program earlier. So let me do this. I will do this. Well, I have been waiting to learn to build an emulator, so I might be able to hit two birds with one. Yeah, definitely. And that's my goal too. I'm still learning Rust, and I never did any kind of emulation before, so I'm still learning. If you see the previous episodes, the very first one, we didn't code. I just reading documentation about emulator and so on. I think I started coding in episode 2, and then now we are almost getting in the display part, which is awesome. So let me do something here. I will, if n equals, so if n equals 0, 9, let's panic. Stop. Okay, I want to stop here because I just want to be sure that we are. Oh. So I made this stop. Okay, don't need. I always forget that we don't need parentheses. Oh. So yeah. We are logging all instructions here. I was pointing with my finger. So yeah, and then we panic it that. Then we can start analyzing this. And let's see. So the program counter is 66. So yeah, we are now stopped here. What I'm really interested is this LCDC. So I forgot to mention that I put all other display registers here in this memory dump because I want to see what's there. So let me get back to one really good Game Boy video emulation display. So this is a JavaScript, and this has this timing. So yesterday we found that, I think that was in Reddit, but that was in emudev, and that it was in Game Boy. Yeah, this. So we already saw somebody else with the same problem here, the infinite loop in this same line that we are. So this guy here said that wherever this li this will be out of the loop when this li gets 90. Yes, because we are comparing. This line is comparing CP is comparing register A with 90, and the register A is loaded with the record of FF44. What is FF44? FF44 is the LI register, and the LY register is used for counting how many lines were drawn actually. So in each line, let me get here. So Game Boy video registers. Yep, I think here and here, maybe here. So here we have, we have here. So here is the LI. The LI indicates that the vertical lines indicates the vertical line to which the present data is transferred to the LCD driver. The LI can take on any value between 0 and 153. The values between 144 and 153 indicates the V blank period. Yeah, so let me explain what's that. So we know that the screen of Game Boy has 160 per 144. So it has 144 lines, like here. Line 144. So the LI counts the line, plus it also counts the time for the pointer for the scanning coming from this point to that one, which we call this V blank. This is the V blank period, and when the pointer goes from here to here, it is H blank. So we have V blank, which is vertical blank, and H blank, which is horizontal blank. So that's why the LI can go to 153. Besides, we have only 144 lines. But okay, so our problem is that the LI line counter is not being incremented, because that should not be incremented by the program that is running. That should be incremented by the hardware of the Game Boy, which we are emulating. So we need to know how to increment that. I mean, we need to know when we need to increment that LI. And here is when. Actually, let me show you something. So we have the main register for LCD, for the display, is the LCDC, which is LCD control register. So this register, which we are dumping here, have these bits. So yesterday we already saw that it's using BG. So it's one, it's background. So the bit 7 says that LCD display is enabled. So, and that was turned on in this line. Oh, here. If you see here, it loads into FF40, the register A, and register A has 991, which I think is this. Let me see. Yeah. So in this line, we turn on LCD showing the background. We turn on those bits. Okay. So from that point forward, we need to start counting our as we are doing the scan line here. So as we need to start counting as our display is being renderized. Yeah. So how we should do that? Well, so that comes us that get us into a new. So basically, the problem is programming the Game Boy PPU and timing it correctly. Exactly. We will need to create the PPU structure, which will be do that, which will a new structure in a new file in Rust, and then we need to make the timing, and we have this documentation here. The timing is based on the CPU clocks, which we is already tracking with our this. We have the timing T and M. I'm not sure. I think we need to use T here, which is the CPU. So we will count these clocks, and every time it passes 80, we will change the GPU, which is PPU, to mode 2, and so on. And when we get this 456, we increment LI, because that means one line was drawn, and so on. Okay, and why is that? Because we spend 8 clocks accessing run, 8 clocks in the scan line accessing vrun, and 204 clocks in this H blank. So the total is 456. Let me just double check that. So 80 plus 102 plus 204. Yeah. So this value is just the sum of this. Okay, so that is what we need to do. And of course, we are starting doing this GPU or PPU. And then matrix is right. They call that PPU, pixel processing unit, and not GPU, like graphical processing unit. I think it's the same, but as Game Boy has this pixel, yeah, let's call that PPU. So yeah, we need to create a new module here. Rust PPU, add that. So mod, see, I also don't remember. Yeah, I need to just yeah, I need to declare it here. So pub mod PPU. When we declare this here in our lib file, Rust will start looking in the lib file, and when it finds just this part, mod PPU, it will the compiler will look for a file called PPU, and it here, and this pub here is to us publishing this mod for other modules be able to use that. If we do not use this pub here, for example, CPU will not be able to use instruction, neither MMU, memory management unit. So we need to do this. Here we don't need to do nothing, we just need to do struct PPU. So what we need to put it here, I think it's a mode, which will be U8. Yeah, just to track this mode, because I think we will need to track this mode. Back here. Yeah. So yeah, well, I think we will need to track these modes. Definitely. Yeah, and I think that's it. I mean, in terms of for now, of course we can put the buffer here. But I don't want to do, yeah, the buffer. And why I'm calling this the buffer? Because for displaying stuff we use this mini FB library. Let me get to the, yeah, this is the C version. Rust mini. So here we are, cross-platform window and from buffer create for Rust. And with a simple vector of integers, we are able to draw something in the screen, and this will that's what we use. This use like each number inside the vector is U32. So there are 24 bits used for the colors. So we have RGB and I think transparency or something like that. So yeah, we can have that here. RGBA, yeah, essentially, exactly. So yeah, RGB and the transparency or something. Do you know what A is standard for? Red, green, blue, and A is I let me see. Alpha, yeah. Thank you, the Matrix. Yeah, alpha. So yeah, I think I will. But remember that besides our screen is 106 pixels per 144, the entire background is 256 per 256. Remember yesterday I showed you guys this video, and here exactly this part. So it is 256 sorry, 256 by 256, but the viewport area is 160 per 160 per 144. So I will let it here as an vec. Yeah. So let implement PPU. So pub function new, and we return a PPU. The default mode will be 0, I think so. And oh, sorry, let me, so let of course my horse, I need to return a PPU here. So then I can do this, and I can return it here. Well, I actually don't need to do this. Let's do this directly. What is wrong? What is wrong? Oh, sorry. But we need to start our buffer, and let's do this. It will be fact of zeros 200, but let's do a constant here first. Just to be okay. Okay, and then we finally need to do something. Okay, we need first we need a pub function to be able to do this, to increment our registers. We call the CPU that do that as run instruction, but this is not an instruction. I saw some other people calling this step, so let's call this step. It receives mutable self, and also this need the memory. Right? It will not return. It also it needs the memory and also the CPU, I think so. Let me think. No. It needs the memory, but it also needs the clocks. So clock, like passed clock it. So no, so naming variables. So clock clocks passed. Let's see. Let's do this. And you wait. So it should be. It could be U size. So what's that? This is basically in each step we need to know how much CPU clocks has been passed to us to be able to calculate it. But there is one thing here. Let me do another. So uh, clocks. Clock. I mean, I will name this like clock, since else no not since. So clock, GPU clock use size. Why that? Because after LCD gets on, we need to also keep tracking of how much CPU clocks we have passed, right? But that's something what's that? Why it's never used, huh? This is weird. Oh, this is will be never used because the new is never called. Oh yeah, I found. So yeah, and how that works? How this should work? So we need to increment our internal clock, then check which mode we are, and then increment change the appropriated PPU registers, LI, LC, etc. Right? So we need to do that. So we should do this like self clock more equal CPU clock is passed. Okay, then match self clock, and is there a way to match with a condition like this? Rust match condition matches expressions. What's that? Rust playground, and here we go. So let's do this. So number, and this number is 10, and then we do this match number. Match wires. Okay, just by example. Okay, so I think it should be something like this, like x if x equals or less than 10. Then I do print ln the number is less than 10. Okay. Actually, we can do this and this. I think so. So, because we are not using X. Grader. How can I grader? Sorry about that. English is not my first language, so I don't know how to spell some words. So grader. Grader. My cat is here. Ah. So the grader, and let's say equals. The number is 10, and that's it. Let's see if that compile. Oh. Expected. Okay, so x y z y z. We expected one of oh. I think we don't use this. Let's do this. So x. As it's complained that the number is not there, I'm just want to discover how to use the, because I think this is the way, or it should be the way. Expected. Oh, maybe this, and this. Oh yeah. Well, panic. Something went wrong. Ooh, say hello. Hello. Wrong. Oh, went wrong. Went wrong. The number is 10. Okay, so I put like 11. The number is less than 10. Oh yeah, of course. The number is greater than 10. Yeah. So yeah, we know how to do that now. Okay, so let's do this here. Can we use the same number, the same name, like this? X, X, X? Should, right? No. Oh yeah, we can, because this is X, X. You have semicolons. Yeah, yeah. I figured that we need to call. Yeah. So we can reuse the names and so. So now we get here, and in the clock we need to do this. So if the clock. So it, like T is T if T less than 80, less equals 80, then self mode equals to two, right here. Then we have this. If less or equals to 72, the mode is 3. And horizontal blank, so 204. Let me see. Yeah, it's 0, and then yeah, and then this is I think actually this is the reverse. Yeah, this is something like this, right? Actually, when it gets 80, it goes to mode 2. When it gets... Oh no, sorry. So, we are in the mode 2 while until we have 80 clocks. So, from 0 clocks to 80, we are in the mode 2. So, we are from 80 to 172, we are in mode 3. From so here is the thing. From 172 to 204. No. Actually, let me. Yeah. So it's 80 plus 172. So here is 252, and here is 47. So 2 here, we are in the line. That's weird because the V blank will only start when we get there. Mode clock. Yeah, it's used this way. I don't know if this is right. Let's change the music for getting more inspiration. Pam pam pam. So yeah, I think that's it. Let's do this for now, because the answer here in this says that Li is about Okay. It says that it's take about 4-6. So yeah, through this. Okay, so here we have this here. So mode 0. And we need to set the mode here. That's interesting. So let me go. Let me try to grab other documentation. Maybe the Pie Boy. But it says not about the timings. Yeah, generating 144 lines means 1 frame. But I want to know about these modes. So let's see if we found it here. Documentation, oh, IO parts, video display, control, yes, that. Here again we see the modes. So here we have the flag that we need to change. Bit 1 and 0, mode flag. Mode 0, 1, 2, 3. See below. 0 during H blank, 1 during V blank, 2 during OEM, and 3 during transferring data to LCD driver. Transferring data to LCD driver means transfer data from VRAM to LCD, I think so, yeah. The 2 lower stat bits show the current status of the LCD controller. The LCD controller operates on 4 MHz. An entire frame is 154 scanlines, or 7,000 dots, blah blah. On scanline 0 through 143, the LCD controller cycles through modes 2, 3, and 0 once every 4 scanlines. 100 are mode 1. Okay, so here completes the cycle. Oh, this dot is the cycle. Yeah. So this is the T number that we have in our CPU. I already saw that. So if we get this if you get this in dot number, that's it. So oh yeah, So it says that duration 100. So I think we need to do something like this, yeah. So yeah. Yeah, we can do this. I think I know. So if we see here, we are counting and resetting the counting every line. So this is one line, this is another line, this is another line. Why? Because the mode 0 happens in the horizontal blank, which is this time, right? So it will happen 144 times. So this will be like doing this 144 times, and then we get the vertical blank. Which will take 100 for okay. So let's do something here. I will do this like mode clock. I will change the name because I like it, this name, mode clock. And I will also do another thing. So I want to count how much lines. This is the same count that we will have in the memory. Should we hold it here and in the memory, or just in the memory? And read memory all the time. Let it there and get that, let this. So function. Yeah, so I think I will do something here. Something that I don't like to do. So let's do this. If I have, we need access to the MMU. So we need an. Can we do this? I think we need to specify lifetimes here. And this is something that I don't know yet. Lifetimes. So lifetime is in structs. Notation of lifetime structs are all similar to functions. Type forward, we choose house to reference. So yeah, see here. All the reference should have, so it should just be something like this. Okay, and this should be okay. So this should receive now we have a reference to the memory. We can't mutate the memory with that. What's that? That's it. Well, I will not use that because anyway that will be not mutable. Yeah. Yeah, the step itself will receive, it should be a mutable. So yeah, I will do something like this. So okay, we don't need the memory management unit inside our PPU structure because we will receive that in the step and we will change that in the step, and also we will read that in the step. So yeah, we don't need to care about it. So and so how oh, yeah, so first, as we saw here, we need to reset our dot counts in each line. Why? Because this repeats in each line. So we count 280, 200. Let me use the numbers here. So we count 280, 107, and so on. So from 80 to 260, 252, and from this, so we have this. This is right. So this is right. Okay, but this is only so this will be panic, not handled mode clock. Okay, and why is that? Because we will do this. If self clock let's do this. This will be something approximately, yeah. So if self clock is higher than this, which means that we already did one line. So we do this. So we need to first let mutable li. So we read. So we read li. So we read what's the so li address is ff44. So what we are doing here, we will read this. Okay, and if we are finish it one line, what we will do? We will increment li. Okay, so let me put it in lowercase just to be, and we will record that write byte. So it is like FF44, and we will record that into li, and we will do self mode clock equals 1 or 0 or any kind. Yeah. Why that? Why is that? So yeah, but then here we have another step, which is so if li, if we already printed all the 144 lines, which means that we are starting the v-blanking mode. So yeah, so here we do this. If li equals 145, so it is 1, and here we have an else. This match only works if we are, so if you are above the 144 line, then the mode will be, then we have the clock. Oh, we need to count these, right? So we can't reset it here. Let me see. Well. So we need to count until the clock is here in increment. Ah, yeah, I think we can do this. So if we are still under the 144, we reset the clock each iteration. Otherwise, we let the clock continue, and then we will be in the mode 1. And all of this happens if self mode is different from 1. Okay, so if we are in this part, we will do this. So we increment the lines and so on. If we are in mode 1, it means that we are doing this v blank. So we don't need to increment a line. Okay. Now we have one more thing to do. So the li we already changed here. I don't know when we need to change the LIC, but we need to change the stat. Why? Why we need to change the stat? Because the stat is the one that holds the mode flag. So, and also holds the interruptions. We are not implementing the interruptions yet. So let me do something here. Okay, so I just changed the music. Boom, 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 boom. So now we need to change the register stat. Well, we can set that like this. I actually don't know. Coincidence flag. Oh. Where is the... Oh. Hardware kick, the monochrome makes it done. So set LC to Y, enable LC. The game will compare. Yeah, so I think, let me see something here. Oh, LC. Well, I think I will implement. I will do this like check LIC behavior, because I know that we need to compare, but I'm not sure who is responsible for setting LYC. Because there is a various reason of interruption. So the set this is something that I don't know who will do this. If that should be on the program, or that should be something other subsystem needs to handle this. So I will not check this here, because if I check it, well, I can check actually. So let me do this. So here we have li, but so I get lic, which is so and let li equals lc equals lic. Okay. So then let's set the stat registry. So then we need to do something here. We need to do so getting back here. So those 3 bits, 5, 4, and 3, I don't want to mess. Actually 6 as well, because that's an interrupt. So I want to mess only with this. So just 3 bits, okay? Okay, so let's do this. I will do let bit 0 to stat bit 0 to 2 equals. So it should be I think if let if how that's let if rust. Yeah, I want to set this, so actually I will do this. So let bit stat bit 2 equals 2. match. Now li equals LC. And then true 1 false 0. Okay, so that's the bit true. So then we can do something like this. No, let me do this. Start page 0 2 2. So our self mode is 0 to 3, so that's why it occupies 2 bits. 1 0 1 2 3. So I want to put that bit here, so I will do something like self mode so let's do this. So 1 yeah. Then I would do this. Let current stat. So it will be bind 41. Then I would do current stat equals current stat and F. So 1 7 6 5 4 3 2 1 0. So I want to clean those 3 bytes. And then I want to do an OR with stat. Why is that problem? just a safe guess. So now we have the current stat. Then we do memory right byte in 0 ff41. So what we did here? Let me try to explain my thoughts, and maybe it's wrong, but so yeah, we will be executing this step on every CPU cycle. So we will be passing how much clocks has been passed since the last clock. So for doing that, I think we need to do something like so CPU clock T last T is size and last M. Why that? Because then I can just count how many clocks passed in this current instruction. So let me use that. So let me run instruction, and also let me put some debugs here. So print well, I don't. Let's see. I will just do this. So let me just put it here. So in the end, I will want to PPU. So I will need to receive a PPU to run this instruction. So the main. So here I will need to have a PPU as well. So PPU, and we have this. Okay. Okay. Why is that? We didn't make it public. Oh, the structure was not public. Yeah, the structure was not public. So yeah, then so here we are. Okay, so here we have a PPU, right? So in every CPU instruction, we should do a PPU step passing the clocks passed. So first we need to do this self last M equals so before executing, we get the self M self T. So now we have like that current struct t clocks equals to last, so self last t minus self t, or better, self t minus self last t. Well, we don't need m as well, so sorry, it's an mm. So now every single, remember this instruction runs in a loop here, okay? So every time we execute one instruction, we will execute this step. We change the mode clock, we get the li, we check if that passed all those, and then we and all of this, wait, actually we only do a PPU step if the LCD is turned on. Yeah, so we need to get let LC DC. So we need to write to read the byte, which is FF. So we are reading the, I think this should be, yeah, we need to only run this, so that's not about CPU, that's about PPU. So PPU should, and the display is enabled if the bit 7 is 1. So we should do this. That is LCD enable equals to LCDC so if this is different than 0, it's enabled. If not, it's, then if that is true, we do if LCD is enabled, we execute all this stuff. Otherwise, we don't need to execute, right? Because what's that? Save LCD. Okay. Hopefully now we don't get stuck. Here, we are not showing anything in the screen yet, but we already have PPU, we already have the timing, like Daymetric said. We are already dealing with timing and PPU. So now we are able to see if that will pass through that CP instructions. So let me just confirm that I don't have penny keys there. Yeah, no. And I don't want to see this as well. And let's see. Yeah, let me turn off the debug. And let's see. So if we pass through this, I think we will found maybe this. I don't know where we will stop. So let me do this. Well, it didn't compile. Oh yeah, we did not initialize it. So here we need to do last t equals 0 and last m equals 0. And yeah. So we have this. Let's see. Not handle mode clock. Why that happened? Oh yeah, because it's get. Yeah, we also need to handle. We also need to handle when it get this. So yeah, we need to do this, and when it get higher than this, we need to do self mode get back to true, because it's a red get back to there. So I need to do this. So this and self mode clock equals to 0. So after this we return to 0. Yeah. So let's do this. Okay. Attempt to add with overflow. Okay. Where? PPU. Here, so it should be. Li equals to li. Oh, yeah. I think I would need to be exactly here. Let me see what's the problem here, because if I make only this, if it is lower than 400, so if it's higher than this, that's it. We are in the 80. Yeah, I think we passed it. The LCD is enabled. The stat is 111000, which is the LI. Okay, so LI can be decimal. I think the best way. LC can be a decimal as well. Oh yeah. So yeah, we are in the 144. We are at passed. Great, we are at passed. So let me see something here. Let me just double check the here. So this is 1 1 1. So we have 0 0. So we are in the mode 0, and the coincidence flag is 1. Why it's 1? Why this is still 1? This is not. Oh, let me check here. Intel, this is weird, why? I think this is the correct way. No. I'm not sure here because this mode clock should be, what's that? Wait. Yeah, the variable here is wrong. It's mode, not mode clock. So, yeah. So stat bit should be, what's that? Not self, sorry. And this be, yeah. Yeah, now it should have. But I think here it should be, now it should be a plus. check if this is wrong. Yeah, I think only these three, and we don't have any of the others set. Yeah, so that's right. So we are now on the 8080. Let me check here. Yeah, we did not implement the subtractions, so we'll do that now. But we are at, so yeah, we are at scroll the logo. See here, increments crown counting. Here, not here, it is here. But that is weird. That is weird. Okay, so we are about 2 hours. I want to let's increment the sub. I would like to see that, to start doing displays actually, like it showing something in the screen. But we did a lot here. We are at, so, but I'm worried about this. Because here it says that it's incrementing scrolling counting. But how that is? Oh yeah, he is dealing with the logo scroll. because here it's changing the FF42 register, which is the scrolling Y. This is actually scrolling up the logo. Oh, yeah, which is exactly the line that we are. We are on the 88. Yeah, it will start scrolling the logo, and that's why we didn't saw this change. Oh, so let's do that. So we have this. Let me just copy this. I think we have all those sub. So sub A, sub B, sub C, sub D, sub E, sub H, sub L, sub HL. Okay, so let me just confirm what is sub is I think it's decrement A from, yeah, subtract N from A, and we are doing already subtraction. So let me go here and put all those opcodes. I will do the opcode like after the decrement. So let's do this. Nope. Nope. Let me find out. Being replaced from current line. I think it is something like. Oh, that's it. So it should be this. Aha. And then we get back here, and then we do 97, 90, 91, 92, 93, 94, 96. So wait. 97, 99, 91, 92, 93, 94, 95, 96, and as usual we have introduce me. Okay. Then we can call of this. Okay, so here's sub A. So so this is yeah. So this is sub B. Sub B is this. And then we have this sub C. C. And D. Well, and D E. A and F. Oh, what else? H. Sorry. H and L. We will deal with HL later. Don't need it now. It will complain. We'll get there. Let's do. And we get in some loop again. See? Nothing happened here. We are in a loop. We need to discover which loop. So how we do that? We turn on our flag. And let it run. It seems that we are stuck in some 64, 66, 64, 60, 60, 64. Again. And why? And why is that? And there I arrived the bug. Oh, wait. Let me do one thing here. We will remove temporary the buffer because these will we are still running. It's crazy how it takes more time. I think it's stuck in somewhere. Every FF, all the instructions are stuck. So yeah, we are here. We are still this 104. I think we got. Oh yes, yes. Here we also need to put Li back to 0. Yeah, we need to put this back to 0. Oh no, actually, yeah, if Li, so this will not enter here. So let me just go print. Yeah, so here and line. Do that again. Yeah, I think we definitely need to I think we need to start handling the this. So if and goes to 0.9, then okay. Yeah, we get there. It always 44, 143. Oh no, that's not true. So let's do this. Okay. Oh yeah, if you see the line 108, you need to, so here if li equals to 100, so if equals to, or let's do this, greater than 100, so then we need to set it back to 0, right? I think then we don't need this anymore. Oh, thank you, Coin you. Thank you very much for the following. Joining us, creating this Gameboy Emulator. We are dealing with a display register right now. So as we can see, we are looping through this. And where we are getting stuck, or this is it. I think we did all the things. Something that should be wrong here. Yeah, but I'm not sure where. We got 2 here. So we jump to here, or we jump to here. And we got here. Then we jump back. So let me do this. I will remove this. As we get this decrement D here, and I think this is the only decrement, I will put some this. So we are here. We get still here a lot of times. So we are looping. I think. Okay, so let me do this. I want to see if we get at this level. So I will do this. So if self PC equals to 0 x a 0, then we print this. Yeah, so if we got that, so if we go here, it means that we are loading this data into the memory, which is actually, I want to see if we are doing that. Yeah, we did it at once, at least. Let's see if we did load it. Yeah, we did. So yeah, I think we get to the point that we have the logo there in the memory already. So yeah, I want to see that. So let me do this. So if I want to, so yeah, I go if you get here. So E60. Are you panic and see? Okay, so now in the memory, I will finally set it there. Okay. Okay, let's see if we have anything. That's weird because we only have this 9. This is weird. Load HL. Okay, so let me see here. Let me see one thing here. What we are doing in load HL. See? I don't think this is the case. Load HL. I think this is the problem. Load HL. So it's something like this. So this is something like the code, so load HL. Sorry. 021. 21. Wait. This is wrong. 20. Oh, 21 here. Load HL. Use 16. So it should be like this. Oh yeah, so this is in the memory, I think so. So let me see. I think I implemented it wrong, these loads. So load HL instruction Gameboy, that's it. So load HL. So load this. Load value into register. Store value into byte pointed. So this is one thing. Let's see one thing here. So this is 36. So 036. No. But this is that way. That is not this way. Oh yeah, we are just copying. Hmm. 00104 is the address for the cartridge there. I think we are stopping here. Let me see. No, we didn't implement it wrong, because this is loaded shell, which is exactly what we did. So let me check this. I think we are not getting to this instruction. Like, and why is that? Because we are not, yeah, we are not getting there because we are jumping just here. And let's see if that's true. So EF should be repeated here. Yeah. So if we change this instead of panic to println, like println, we will keep seeing that. Yeah, because it gets to here and loop, because this comparison, it's not okay. Oh yeah, I think I know what's going on here. Let me do this. So here, let me stop the sound. Why we are not seeing the actual logo inside the memory? Because the logo itself is loaded after this check. I think somewhere here. It's loaded by the cartridge. I think so. So if we don't, if we have the cartridge, it will. So that's
all this is controlled by something like this. They played with kilobytes.
It's something.
Well, some games only need 32 kilobytes. Tetris fits nicely into 32 kilobytes. There's a single chip there.
No.
You can swap the low and the high nibble. They added 8 instructions there. And there's an extra power saving instruction. So this is what the opcode table looks like, just to get an idea from the color coding. Chime. This Boot Rom is built into the Game Boy, and took a while until this was extracted. It was a real pain. After that, it also checksums the header just to make sure that you don't have to blow into the pins.
Yeah.
And then something like this, they played. It does get compared.
Here. That's what I'm saying. If there is no cartridge, I wish that too, Conan. You, yeah. I think I will put some timestamps there, in the comment. I wish that too. So here, we have this. When we turn on the Game Boy without a cartridge, we see this as, like, instead of Nintendo logo, a black, and only the trademarks there. And I think that little trademark is those 49, 49, 49. This in the memory, and all the rest is 0 because it's black. So if now we draw that in the screen, we will be able to see exactly this. And then we need to start working with a real cartridge. So yeah, I think we need to actually use that mini frame buffer library and start writing that to the screen. So yeah, it's too late for starting that now, but at least I discovered that, well, what we did today. So let's recap. I will just git status, git add, git commit, uh, implement initial PPU and timing and PPU timing. So git push. So everyone that wants to see the code, it's there in my GitHub. Uh, so let's recap what we did today. We achieved a lot of things today. We create this PPU struct, which will have a buffer inside, but it has a mode and mode clock. The mode clock is the counter that based on the CPU clock, which is received. So yeah, so that's the mode and mode clock, and how this PPU works. Uh, on every, so let me remove this print. Yeah, let me put like that. Remove the bug. So in every iteration of the fetch, decode, and execute flow, after that we will count how many clocks passed and pass that to PPU step. The PPU step is will do first we will check if LCD is enabled. Yeah, so because if LCD is not enabled, we don't need to do anything. And that is the very first bit of this FF40 register. Then we need to start checking which line we are we are handling, because we need to increment that line after passed 456 clocks. And we also need to change the mode on depending on the size of the clock, because we have mode 2, 3, 0, 1, and 2 again, and each one means one thing. The 2 is reading OEM, 3 is reading VRAM, 0 is H blank, and 1 is bleed blank. So we are looping through this and changing the mode, also incrementing the LI record register. So we are incrementing that, and we also when we get to 153, we put the LI back to 0, because besides having only 144 lines, it goes to the 153 because of the H blank. Yeah. So what else? And then we set this register, which is the stat register. It is FF41. So doing that, we were able to see that our emulator running the boot ROM, running only the boot ROM, it gets stuck here. And why it gets stuck here? Because the boot ROM compares the logo inside a card with the logo inside the image. We actually can go through this without the display yet. We can go through this only using a real ROM, and when we are using a real game ROM, we need to first while it's executing this, we need to overwrite the first 255 bytes with this boot Rom, and when it gets here, it will not jump, then it will execute to the end. I think so. Yeah, we can actually see that instead of implementing the display yet. But yeah, I think we need to see that display happening. So yeah, tomorrow we will start implementing the display. I mean, displaying something in the screen. Today we did the PPU stuff, and tomorrow we will display something. But of course, tomorrow we will be displaying this. If we achieve this, that's okay. But I will try to also do that thing to use a real ROM. And if you get that, that will be amazing. So, folks, thank you for watching. Thank you for the comments. We are start chatting now during the streaming. That's awesome. Tomorrow will be a very good day. I mean, we will be seeing something in the screen. Yeah, I promise that we will focus on that tomorrow. Now we are in a good shape here to start with displaying stuff. Okay, so thank you everybody. Thank you for watching. This video will be uploaded to my YouTube channel, which is in the description of Twitch. And see you tomorrow. Thank you for watching.